Have you ever watched a lunar eclipse and wondered if the moon's dance with Earth's shadow could do more than just dazzle us in the night sky? Could it perhaps shake the ground beneath our feet? Today, we're diving into an intriguing question. Can a lunar eclipse trigger increased seismic activity, like earthquakes or volcanic eruptions? Let's explore the science behind lunar eclipses, the forces at play, and whether the moon's alignment with Earth and the sun could really stir up our planet's crust. First, let's break down what a lunar eclipse is. A lunar eclipse happens when Earth passes between the moon and the sun, casting a shadow that temporarily darkens the moon. This occurs only during a full moon, when the sun, Earth, and moon are aligned in a straight line, a configuration called syzygy. The moon slips into Earth's shadow, sometimes turning a striking reddish hue, earning the nickname blood moon. It's a beautiful cosmic event, but could this alignment have a deeper impact on Earth's geology? To answer that, we need to understand the forces involved. The moon exerts a gravitational pull on Earth, most noticeably seen in the tides of our oceans. These tidal forces aren't just limited to water, they also affect Earth's crust, causing slight deformations in the solid ground. These are called Earth tides, and they're subtle, typically moving the crust by just a few centimeters. During a lunar eclipse, the alignment of the sun, Earth, and moon could, in theory, amplify these tidal forces because the sun's gravity adds to the moon's pull. This combined gravitational tug creates stronger tidal effects known as spring tides, which happen during full and new moons. But here's the big question. Could these amplified forces be enough to trigger seismic activity like earthquakes or volcanic eruptions? To explore this, let's look at the science of earthquakes. Earthquakes occur when stress built up along tectonic plate boundaries is released, causing the ground to shake. Most earthquakes are driven by the slow, relentless movement of these plates, which build up energy over years or even centuries. The idea that a lunar eclipse could trigger an earthquake suggests that the extra gravitational pull might act like a final nudge, releasing pent-up stress and fault lines. It's an appealing idea, but does the data back it up? Scientists have studied this question for decades, looking for patterns between lunar phases, eclipses, and seismic events. Some early studies suggested a possible link. For example, a 1970s analysis of earthquake records hinted that seismic activity might spike slightly during full and new moons when tidal forces are strongest. Since a lunar eclipse happens during a full moon, this could imply a connection. However, more recent and comprehensive studies have poured cold water on this idea. A 2018 study published in Seismological Research Letters analyzed thousands of earthquakes over several decades and found no statistically significant increase in seismic activity during lunar eclipses or full moons. The researchers concluded that the tidal forces, while measurable, are simply too weak to trigger earthquakes on their own. But what about volcanoes? Could the gravitational pull of a lunar eclipse push magma chambers closer to eruption? Volcanic eruptions are driven by pressure from molten rock and gases beneath Earth's surface. In theory, tidal forces could influence magma movement, especially in volcanoes already primed to erupt. A few studies have explored this, particularly with volcanoes like Mount Etna or Kilauea, which are known for frequent activity. Some data suggests a slight correlation between lunar phases and volcanic unrest, but again, the evidence is far from conclusive. The tidal forces during a lunar eclipse are only marginally stronger than during a regular full moon, and the difference is often too small to make a meaningful impact. Let's put the forces into perspective. The moon's gravitational pull is about 1/1,000,000th of Earth's own gravity. Even when combined with the sun's pull during a lunar eclipse, the additional stress on Earth's crust is minuscule compared to the massive forces driving tectonic activity. Think of it like a feather landing on a sleeping giant. It might cause a tiny stir, but it's unlikely to wake the beast. Most earthquakes and eruptions are triggered by processes deep within Earth, like plate subduction or mantle convection, which dwarf the influence of tidal forces. That said, the idea isn't entirely without merit. In rare cases where a fault or volcano is already on the brink of activity, the extra tidal stress could theoretically play a role. Imagine a glass filled to the brim with water. One tiny drop could cause it to overflow. Similarly, a fault under extreme stress might be nudged into slipping by tidal forces, but this would be an exception, not the rule. Scientists estimate that any tidal contribution to seismic events is so small, it's nearly impossible to measure against the natural variability of Earth's tectonic systems. So, where does this leave us? The consensus among geologists and seismologists is that lunar eclipses don't significantly increase seismic activity. The gravitational effects are real but far too weak to compete with Earth's internal forces. However, the question itself highlights the fascinating interplay between celestial mechanics and our planet's geology. The moon's pull shapes our tides, and its influence on Earth's crust, while subtle, is measurable. Yet, when it comes to earthquakes and volcanoes, the moon is more of a bystander than a mastermind. Next time you watch a lunar eclipse, marvel at the cosmic ballet unfolding above. The moon may cast a shadow across our skies, but it's unlikely to shake the ground beneath us. Still, the idea that the heavens could influence Earth's restless crust reminds us how interconnected our planet is with the cosmos. Keep looking up and stay curious. There's always more to discover about our dynamic world and the universe beyond.